Okay. Now, in the monetary approach to the exchange rate, we have the problem that the exchange rate, which we denote by ST, is defined in an inverse way, in the sense that for this model, not for your book, but for this model, the exchange rate is defined as the quantity of national currency for 1 unit of foreign currency. So it's the opposite. It's not like the euro-dollar exchange rate. So in this model, we define the exchange rate as the quantity of national currency for 1 unit of foreign currency. It's the opposite. This implies that, given this definition, an increase in the exchange rate is an appreciation or a depreciation, given this definition. Depreciation, perfect, because we need more national currency for 1 unit of foreign currency. Okay, we have just seen the uncovered interest parity. The uncovered interest parity can be expressed in this model, and the assumption is free, in order to have the uncovered interest parity, that we have free capital movement, okay, between areas. In the monetary approach to the exchange rate, we consider what is called a small open economy. Is small in the sense that the foreign interest rate is given. This economy is not able to affect foreign interest rate, okay, which is exogenous for this economy. How we can express the uncovered interest parity? Again, if we define by small s of t the natural logarithm of the exchange rate, this is a definition, so we can use 3 line. The derivative respect to time of this variable, we had just seen, but I show you again, will be equal to the derivative respect to time of the exchange rate respect to the level of the exchange rate. We have seen this, given this definition. Okay? So it's the percentage change in the exchange rate. What is S dot T? Is the derivative with respect to time. Okay? Now, the uncovered interest parity, in this case, can be written as interest rate at time t equal to foreign and exogenous interest rate because we are considering a small open economy, plus the percentage change in the exchange rate. This is the uncovered interest parity in continuous time. It's the same we have seen before, but now we are in continuous time. This implies that if the internal interest rate is greater than the foreign interest rate, I can show you. If IT is greater than star, this implies S dot T greater than 0, which means that we have an actual and an expected depreciation, because we are in a deterministic framework. So actual and expectation are the same. But this model is able to show us the dynamics of the exchange rate. So we have in a continuous time, the expectation and the actual change are the same. Okay. What is the difference with respect to the previous case? The previous case, we have seen the actual exchange rate and the expectation. Here we have a change which is equal to the expectation, because we are in a deterministic and continuous framework. If the interest rate, the internal interest rate, is lower than the foreign interest rate, what we have is that S dot t is lower than 0, which implies negative percentage change in the exchange rate. So an appreciation in the exchange rate. If the interest rate is equal, the internal interest rate is equal to the foreign and exogenous interest rate, S dot t will be equal to 0, no change in the exchange rate. I know that this sounds strange, because if the interest rate is greater than the foreign, you expect an appreciation. But this is the expectation. The expectation is of a depreciation in the exchange rate. In the deterministic framework, actual and expected change are the same. And this is the first assumption in the monetary approach to the exchange rate. Our second assumption is the purchasing power parity. But we need to express this condition in continuous time and using this definition of the exchange rate. So we have that the purchasing power parity implies that internal price should be equal to the exchange rate which multiplies foreign price. Also foreign price are exogenous here. The internal price are equal to the exchange rate which multiplies foreign prices, but this is now the purchasing power parity because of the definition of the exchange rate. Because now the exchange rate is the quantity of national currency for 1 unit of foreign currency. If we consider the log of each variable, so we call small pt is defined as the natural logarithm of the level of internal price. S of t is defined as, we know, natural logarithm of the exchange rate, and small p star is defined as the natural logarithm of foreign price. This condition can be expressed as small p t equal to small s plus small p star, because we log properties. Okay, this is just a way to write the purchasing power parity using logarithms. If we consider the derivative with respect to time of this expression, we get that small p dot will be equal to s dot t plus p star dot, which is the same we have seen with the inflation rate, because this gives us the relation between internal and the external inflation rate, because the derivative of the log is the inflation rate. Just for example, small p dot will be equal to p dot t divided by pt. This is the inflation rate given the price index. is the internal inflation rate. The same for the exchange rate. So this equation says to us that the internal inflation rate is equal to the foreign inflation rate plus the percentage change in the exchange rate, as we have seen before. But now we are in continuous time. Now we need differential equation. Okay, now I want to show you the why in this approach we need to solve forward our differential equation, and why in this approach the exchange rate is globally unstable. We know the definition of global instability, or we should know from previous lecture. In order to understand this point, we start with the equilibrium in the money market, because this is the monetary approach to exchange rate, so we need the equilibrium in the money market. In money market, we have money demand and money supply. You know. So we have the real money supply that we can call MT over PT, is a real money supply at time T. In equilibrium should be equal to money demand. What is money demand? It is a function of, we can also write here, consumption at time T, or income. You can consider income on consumption is the same, okay? Because it's the part of money demand which depends on transactions, okay? And on it is a function of the interest rate, money demand. Consumption has a positive effect on money demand. Interest rate has a negative effect. I cannot explain you why, because you know why. Why? So if there is an increase in interest rate, you have a reduction in money demand. Assuming that this function can, we can express the so-called IS relation. What is the IS relation? It's a relation between the interest rate from the previous equilibrium, sorry, the LM relation, not the IS, is a function of real money stock and consumption. Okay? We know that real money stock has a negative effect on interest. And consumption has a positive effect. Why real money stock has a negative impact on interest? Because it's a restrictive, is an expansionary monetary policy, leads to a reduction in interest rate. Okay. Now we use both the uncovered interest parity and the purchasing power parity. The uncovered interest parity was IT, the internal interest rate, equal to foreign interest rate plus the percentage change in exchange rate, right? S dot T, which implies S dot T, so percentage change in exchange rate, equal to interest rate differential, IT minus I star. Okay? But IT can be obtained from the equilibrium in the money market. That's the reason why we call monetary approach to exchange rate. So S dot T will be equal to a function of real money supply in consumption minus foreign interest rate. Now we apply the purchasing power parity. We can apply the purchasing power parity on the denominator of the real monetary stock. This differential equation is a differential equation. Can you see? You have the derivative respect to time of exchange rate. You get S dot T equal to a function of real money stock. Now we apply the purchasing power parity. The level of price PT will be equal to the exchange rate ST, which multiply foreign price, given the purchasing power parity. Consumption minus the level of foreign interest rate. Now, in order to have an idea of the dynamic instability of the exchange rate, we need to consider I give you the result because it's too difficult to understand, but it's easy to check that the derivative of S dot T respect to the exchange rate is greater than 0. You can see on the PDF, okay? But it's easy to check that this condition is greater than 0. If you want, this derivative will be equal to, no, I want, it's better to skip this for now, okay? It's too difficult. Why we are interested in this derivative? Because this derivative is useful to understand the stability of the exchange rate. I'll show you now. The so-called phase diagram. If this derivative is positive, the phase diagram of the exchange rate is this. I write derivative of S dot T respect to the exchange rate is positive. So if we consider S dot T respect to the level of S of T, this function is positive. Is not positive, is increasing because the derivative is positive. We assume it's linear, okay? But if this function is positive, so in this case, the steady state or the equilibrium solution of the exchange rate we can call S bar is globally unstable. Is globally unstable, meaning that if we start from here, from an exchange rate equals to S prime, the percentage change is positive. So we have a continuous depreciation. Increase in exchange rate means depreciation. If the exchange rate is lower than the steady state, a level S second, in this case, the percentage change is negative. Is negative. Is negative. So in this case, the exchange rate will appreciate forever, eventually until zero in absolute value, not in log, okay? So this diagram is useful to understand that in the monetary approach to the exchange rate, yes?
In negative derivative will change.
Sorry?
In negative.
Yes?
Derivative will change. It will be less than.
Yes, because this is the log. So it's possible that you go also on the negative part, okay? Because this is the log of the exchange rate. But the minimum value of the exchange rate is zero. Zero national currency for 1 unit of foreign currency. But it's not the maximum value of the exchange rate of the exchange rate is zero in the sense that the exchange rate can appreciate until zero. Okay, but this is no, it's until zero. It's zero. Sorry, because this the value is the level of the exchange rate. It's until zero. It's the level. It's big less. Okay, it's not small less. So we have this dynamic instability of the exchange rate. And when we have, in order to solve this problem, we will introduce the hypothesis that the exchange rate is not a backward variable, but is a forward variable. So it depends on future. And we need to solve the differential equation forward-looking instead of solving the differential equation backward-looking. Anyway, there is also an economic intuition for these dynamics. What is the economic intuition? Well, suppose that the exchange rate becomes S prime, so we have a depreciation in the exchange rate. So S prime implies what? Implies an increase in S of t, in the exchange rate. Given the purchasing power parity, this implies a reduction in real money stock. We denote it by M divided by P star S of t using the purchasing power parity. If we have an increase in the exchange rate, we have a reduction in real money stock. Why? Because the purchasing power parity holds. So the denominator increases. And this leads to an increasing interest rate. If there is a reduction in real money supply, we have an increase in interest rate. But using the uncovered interest parity, the interest rate can be higher than the foreign interest rate only if the exchange rate depreciates. Only if there is an expectation of depreciation, which implies an actual depreciation. So this is circular, and the exchange rate depreciates forever. So this process will continue until the real money stock will reach a level equal to zero. But the opposite, if we consider a level of exchange rate as second, which is lower than the steady state. In this case, we have a reduction in the exchange rate, which will imply an increase in real money stock, given the purchasing power parity. If the real money stock increases, the interest rate decreases in the money market. And this is possible given the uncovered interest parity. The interest rate can stay below the foreign interest rate only if the exchange rate expectation is an appreciation in the exchange rate, so a reduction in the exchange rate, a further reduction. So also in this case we have a circularity with a continuous appreciation in the exchange rate and a continuous expansion in real money stock, which goes to infinite with the reduction in the exchange rate. So the exchange rate in this case will appreciate forever. This is the economic intuition that we can use. We can use to understand why in this model, this monetary approach to the exchange rate is dynamic, unstable, is globally unstable. So we need to solve forward this model, which means that if the exchange rate is outside the steady state, the exchange rate is able to jump to the steady state because it depends on expectation about future. There is a possibility for the exchange to jump, because if we haven't this possibility, this system is unstable. But we will see tomorrow, I think. Okay? Thank you.